Okay, folks, so in this video, I want to go over the topic of sets. The purpose of this video is really just to go over the basic principles of sets with specific emphasis on set notation. In a later video, I will be doing specific examples of sets questions. But for anybody who's looking to do revision of their basic notes for sets, this is the video for you. So first of all, what is a set? Well, a set can be defined as any clearly described list of items. Okay, so that's what we mean when we say a set. So it has to be something that's clearly defined. So for example, we could say the set of months with the letter B. Okay, this is clearly defined. We know exactly which months of the letter B. And also, I should say, we always name our set, and we name them with a capital letter. So we'd say the set A of months. So how we'd write this is we'd say A is the set of months with the letter B, like this, or we can start using a notation. So we'd say capital A is equal to curly brackets, and it's important, folks, that we use these curly brackets. In maths, the only time you use these curly brackets is when we're dealing with sets, okay? And if you're dealing with sets and you don't use curly brackets, you're going to lose marks because the examiner won't immediately know you're using a set or you're doing a sets question and you're not using the proper notation. So it's important to use these curly brackets. So months beginning with the letter B, well, the first would be February, okay? Then we'd have September, October, November, and December. And then we close our curly bracket. So that's a clearly defined set, okay? Now, if I said the set B or C, the set C is the set of the best months of the year. Well, that's not a set, because what's the best months of the year? Who decides that? Is the best months of the year June, July, August, because it's the summer holidays? Is the best months of the year November, December, because you might have snow? Like, it's not clearly defined. So that would not count as a set, okay? So what about a bit more about our notation, okay? When we're doing it, as I said, we list the items like so, and each of these things, these items that's in our set, is what we call an element of the set, okay? Now the symbol that we use to represent this is this kind of elongated capital E. It looks kind of like the euro symbol, okay? So that's the set of, that is the symbol for an element, and an element is defined as an item in a set. So if I have the set C is the first 5 natural numbers, and we all remember natural numbers, they're the whole positive numbers. That would be C is equal to, curly brackets, 1. And also, I forgot to include, you include a comma between each element. 2, 3, 4, 5. So we could now say 4 is an element of C. So how we say it is 4, elongated capital E, C. And there we're saying 4 is an element of C. Okay? So we have elements is the name for the items in a set, and a set is a clearly defined list of items. Okay, we write the elements of our set inside curly brackets, and you should always write them in order if there is an order, okay? And we use capital letters as the names of our sets, all right? So, well, what if I have a clearly defined set, but it doesn't have any elements? So let's take, for example, the set Y is the months of the year containing the letter W. Well, in the English language, there are no months of the year with the letter W in them, okay? So is this set clearly defined? Yes, it is. We know exactly what we're talking about here. We're talking about months of the year that contain the letter W. However, does this set actually have any elements? No, it doesn't. So what do you do with a set that has no elements? Well, an empty set okay, which is one with no elements, is called a null set. Okay, so if it's an empty set with no elements, it's clearly defined but has no elements, then it is a null set. Okay, now there are two symbols in maths to represent the null set. Okay, the first is a 0 or an O with a diagonal line through it, or the second is a set of curly brackets. Okay, so there you go. So you have null set, which is a set which contains no elements. Right, so let's look at some more notation. Okay, what if we have equal sets? Okay, so two sets that contain exactly the same elements, or two sets which contain the exact same elements, but one contains more than the other. So we'll see what we mean by that, okay? So if we say, go back to our first example, A is the set of the first 5 natural numbers, and B is the set of the first 3 odd natural numbers, and if we look at this, A is equal to 1, 2, 3, 4, 5. B is equal to 1, 3, and 5. Every element that's in the set B is also in the set A. But there are elements of A that are not in B. So we would say that B is a subset of A. And there is a symbol for this. Subset is a elongated C. Okay? So there we go. All right? Now, something to be aware of, we have what we call proper subsets and improper subsets, okay? The example I had above of this subset B, which is subset of A, would be called a proper subset. So when we say this, we mean a normal scenario where you have two sets. One is a list of elements, the other is a smaller list of elements, all of which are in the first one. That's an example of a proper subset, okay? Now, things to note. Every set is a subset of itself. Okay? And also, the null set, which is the set which has no elements, is a subset of every other set. These are two examples. A set which is being described as a subset of itself, or the null set, are improper subsets. Because technically, by definition, they are subsets. They contain elements which are in another set, but they're not really what we mean when we say it. So they're called improper subsets. All right? Now, there's no symbol for improper subsets. It's just like that, okay? So next, we want to talk about the topic of illustrating our sets. So how do you illustrate your sets? You illustrate them with what's called a Venn diagram, okay? So a Venn diagram is quite simply a circle which shows all of the elements in a set, okay? So if I go back to my set A, how we'd illustrate this would be circle, and then 1 with a dot beside it, 2, 3, 4, and 5. Now it's important that we put a little dot beside each of these, okay? Because the little dot means that this 1 is the element 1, the number 1, which is an element of my set. If I had a number without a dot in it, then we'd have what's called a cardinal number, which isn't saying this number is an element, but it's saying this is the number of elements in my set, okay? And we'll get onto that again in another example in a minute, okay? What if I have, say, 2 diagrams, okay? Or rather 2 elements. So let's say we've got the set A. We're sticking with our 1, 2, 3, 4, 5. Okay, and then I got the set C, which is the first 5 odd natural numbers. 1, 2, 3, 5, 7. No, damn it, 2 is not an odd number. Let's try that again. 1, 3, 5, and it'll look wrong, 7, and 9. So, we'll need one circle to represent A, and we'll need another circle to represent B. Now, whenever you're doing Venn diagrams which involve more than one set, you always get your circles to overlap. And the reason we do this is because there might be elements that are shared, and that's in this intersection where they overlap. So any elements that are in both sets, we want to put in here. So let's look through them. Well, the element 1 is in A and it's also in B. So we're going to put it here. 2 is in A, but it's not in B, so we put it here in the bit of the set A, but that's not also touching B. It's not overlapping or in B. 3 is in A and 3 is in C. So we put them in the intersection. 4 is in A, but 4 is not in C. 5 is in A, and it's also in C, so we put it in the intersection. And then we have 7, which is in C, but not in A, so 7 goes here. And then we have 9, which is in C, but not in A, so 9 goes here. So now we've got clearly defined Venn diagram. We're showing all of the elements that are in A are in this circle. 1, 2, 3, 4, 5. So they're all there. All the elements of C are in this circle. 1, 3, 5, 7, 9. The only thing is these two circles overlap, and this bit here, the overlap called the intersection, is where these elements that are in both go. Now, intersection is the elements in more than one set. And there is a symbol for this. The symbol is a funny kind of upside down U or elongated N. Okay? So we have intersection. Another thing I can have in a Venn diagram is I could have what's called the union, which is the list of all elements in all sets. So we list all the elements in our set. So this is quite easy. Now, by the way, the symbol for this is a capital U. Well, sort of a capital U. It's not an actual capital U because that's a capital U with a little line. It's a capital U without the little line, okay? So, oh, by the way, going back to my intersection, if I said A intersection B, then I'd be saying I want the set of elements that are in A and in B, and that would be 1, 3, and 5, okay? If I want A union B, that is the set of all the elements that are in both A and in B. So that would be 1, 2, 3, 4, 5, 7, and 9. No, we do not repeat elements. So I have 1 is in A and 1 is in C. I keep saying B. Okay, so sorry, I keep saying B when I mean C. Okay, so we have 1 which is in A and 1 which is also in C, but we don't write it down twice. We only write it down once because it's only once here. Okay, so there you go. Simple enough. Okay, so the union of an intersection, or sorry, the intersection of a Venn diagram is this bit. And you could be asked, illustrate on a diagram where the intersection is. And that's this. And then the union is the whole thing. Okay? So, next we have what we call the cardinal number of a set. Now, a cardinal number is a number of or amount of elements in a set. So sticking with our original example, 1, 2, 3, 4, 5. The cardinal number of A is equal to 5. Why? Because there's 5 elements. There is a symbol for cardinal number, and it is the hashtag. So we could say hashtag A is equal to 5. If we go back to our previous example, we could say hashtag A union C is equal to 1, 2, 3, 4, 5, 6, 7. Okay? And going back to what I was saying about drawing diagrams, okay, we would say that if I've got the Venn diagram for A, If I just put down a 5 here, then what I'm saying is this set A has 5 elements in it. If I put an A 5 with a dot beside it, I'm saying the number of 5 is an element of the set A. So don't be confusing the two things. Okay? Next we have what is called the universal set. Okay? So the universal set is a set containing all other sets. So it's like a superset. And it is represented by a capital U with an actual capital U with a line, and it's a rectangle. So if I go back to my previous example of A and C, I would write it like this. So let's say U is equal to the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. A was the first 5 letters of the first 5 natural numbers. And C was the first 5 odd natural numbers. Okay, so we shall write this, draw this a bit bigger. Yeah. So 1 is in all of them, so it goes in the intersection. 2 is in A, it's in U, but it's not in C, so it goes here. Okay, now you might say, but why is it going here? Well, if it's going here, it's also still inside the rectangle. Okay? So 3 is in all of them, so it goes here. 4 is in U and it's in A, so 4 goes here. 5 is in all of them, so it goes here. 6 is in U, it's not in A and it's not in C, so it's going to go outside here in the rectangle but outside the two circles. 7 is in U and in C, so it's going to go here in C. 8 is in U but in none others, so it goes here. 9 is in U and C, so it goes here, and then 10 is here. So that's how you draw a universal set. Okay? Now we have a thing called complement, which relates to universal sets. So if I'm looking for, say, the complement, and complement is the elements in the universal set but not in the other sets. Okay, so if I wanted a complement, oh, and by the way, complement is represented with this little tick. I'd want all the elements that are in the rectangle except for the ones in the circle A. So that would be 7. And you might say, but sir, 7 is, oh, actually, we'll start off with the lowest 6. 7, we say, sir, 7's in C. Yeah, but it's not in A. I don't care that it's also in C. I said A complement. So I want the stuff that's in this, but not in the circle A. So 6, 7, 8, 9, and 10. Okay? C complement would be 2, 4, 6, 8, and 10. And A union C complement would be everything in the rectangle except for what's in both of them. So it would be just 6, 8, and 10. So that's complement. So I think I'm going to leave it there for now. Okay. I want to just quick recap of the symbols. The first one was element, which is an item in a set. And the symbol for this was the funny E. Now, if something is not an element of a set, we would symbolize that with the E with a line through it. Okay? Next, we have a subset. A set whose elements are also in another set. Its symbol is this long C, and if it's not a subset, it's a line through it. We have the null set, which is a set containing no elements. And its symbols are the 0 with a diagonal going through it or a pair of empty curly brackets. Okay. We then had intersection, which is the set of elements shared by two sets. Two or more sets. And that's a upside down kind of U. We have union, which is all elements in our sets. By the way, intersection was this bit of a Venn diagram. Okay, union is the weird U, and union is all of it. And then you had complement, which was the little tick, which is the elements in the universal set, but not our other name set. Okay, so there you go. That's it for now. As I said, this is a quick overview of the basics of set and set notation and set symbols. I hope this helps you with your study of sets, and I shall talk to you soon. Okay, thanks. Bye.